Today we're talking about air navigation technologies without hesitation, repetition, or deviation starting now. Airborne navigation relies on a combination of onboard avionics, ground-based navigation aids, and global navigation satellite systems like GPS. The aircraft's avionics systems are key to navigating the skies, constantly receiving and processing data from these sources. This interaction between the onboard systems and external navigation aids ensures accurate positioning, heading, and altitude information, allowing aircraft to follow predetermined flight paths. Here is a list of important navigation technologies, and we'll be talking about them in detail in the same order. Starting off with the Flight Management System, or FMS. The FMS is an onboard avionics system that integrates several navigation functions to provide pilots with essential information. It includes components like the flight management computer, navigation systems, and automatic flight controller guidance system. The FMS also works with the electronic flight instrument system, presenting critical flight data to pilots. It's a central hub for managing flight plans, navigation, and automatic control of the aircraft during flight, improving efficiency and accuracy in various operations. The magnetic compass, which is a fundamental navigation tool, points to magnetic north, giving pilots the directional information they need to maintain their heading. While the magnetic compass itself is subject to variation and deviation, which are corrected before use, its readings are used to feed data into more advanced navigation displays such as the heading indicator, which serves as a primary reference for direction of travel. Area navigation, or RNAV, allows aircraft to fly a predetermined flight path by referencing waypoints, which are specific geographic coordinates. It offers more flexibility than traditional navigation methods, enabling aircraft to follow direct flight paths rather than navigating from one ground-based navigation aid to another. RNAV systems are usually integrated with the FMS and may rely on multiple navigation sources like VOR, DME, and GPS. By connecting waypoints in a seamless and efficient manner, RNAV systems improve flight path management and reduce flight time. Next up is Distance Measuring Equipment, or DME. The DME is a ground-based transponder that measures the slant range distance between the aircraft and the ground station. Pilots use DME to determine how far they are from a VOR DME station, and this information is crucial for accurate positioning. Similar to how secondary radar works for air traffic control, DME provides precise distance data to pilots for navigation, especially during en route operations. Next, we're talking about the Instrument Landing System, or ILS. The ILS is a precision approach system that assists pilots during landings. Its two main components are the localizer, which provides lateral guidance aligned with the runway centerline, and the glide slope, which provides vertical guidance, helping pilots maintain the proper descent angle. The ILS is crucial for landing in low visibility conditions, ensuring that aircraft can land safely and precisely on the runway. The Inertial Navigation System, or INS, is an onboard system that senses the aircraft's movement and rotation, providing critical data about speed, altitude, and dead reckoning position. It operates independently of external navigation aids by tracking the aircraft's internal motions. This data is compared with inputs from other navigation aids like VOR and GNSS, making it an essential tool for long-haul flights or operations over areas with limited ground-based navigation support. The Non-Directional Beacon, or NDB, is a low to medium frequency ground-based radio transmitter that emits signals uniformly in all directions. Unlike VOR, which requires a direct line of sight, NDB signals follow the curvature of the Earth, making them accessible to aircraft at lower altitudes and over greater distances. Pilots use NDB signals with onboard direction finding equipment to track bearings towards or away from the beacon, making it a reliable aid for non-precision approaches, especially in remote areas. Tactical Air Navigation, or TACAN, is a military navigation system that provides slant range distance from the aircraft to a ground station similar to DME. It is often paired with VOR to form a VORTAC station, offering DME capabilities for civilian aircraft, while military aircraft can take advantage of its additional features for en route navigation and non-precision approaches. VHF Omnidirectional Range, or VOR, is a ground-based electronic navigation system that uses very high frequency signals to transmit information in 360 degrees. Pilots can use VOR signals to determine their magnetic bearing or radial to or from the station. VOR stations are essential for navigating airways and performing non-precision approaches. Lastly, we have satellite-based navigation. These global navigation satellite systems, such as the GPS from the United States, GLONASS from Russia, and Galileo from the European Union, are space-based systems that provide highly accurate position, time, and velocity data. These satellite systems are widely used for navigation, especially in areas without ground-based navigation aids. They allow for direct flight paths and non-precision approaches, revolutionizing global air navigation by offering unparalleled precision. In summary, these navigation technologies, ranging from traditional ground-based systems like VOR and DME to advanced satellite-based systems like GPS, are integral to the safe and efficient navigation of aircraft. They provide pilots with real-time data on positioning, heading, altitude, and distance, guiding aircraft through all phases of flight and ensuring successful operations even in complex environments. If you liked this video, don't forget to hit the like button, leave your thoughts in the comments, and subscribe for more aviation content.